In this video, we're going to be finding general solutions to differential equations using separation of variables. So let's start by talking about separable differential equations. So we have kind of a generic equation down here, dy dx equals some function of x times some function of y. In this case, the variables can be separated. So here's what it looks like when we separate it. If I take this first equation and I divide by f of y on both sides, and I multiply by dx on both sides, notice my left side of the equation only has y's in it, and my right side of the equation only has x's in it. In this video, we are going to want to know what y equals. So in order to do that, we can integrate both sides of the equation. In this case, on the left side, we're integrating in terms of y. On the right side, we're integrating in terms of x. Once we do that, we should be able to solve for y. So that is what we are doing. Let's go through a few examples. Starting with this first one, again, our goal is to figure out y equals what? And we want that to be a function of x. First thing I'm going to do is this says y prime, that's the first derivative. It might be better to rewrite it as dy dx. It means the same thing, it's just in a different notation. So on both sides, I'm going to multiply by y, and then I'm also going to multiply by dx. Notice that we have separated the variables. I have all my y's on one side and all my x's on the other side. Once you've done that, you're going to integrate both sides and do your standard methods of integration. So for the y's, this is going to be 1/2 y squared. It is going to be a plus c, but hold on one second. On the right side, we're going to have x squared, and we are going to have 1/2, but I already have the 2. So the 1/2 and the 2 make 1. And then I'm just going to put a plus c on the right. Now, it is technically 1/2 y squared plus c, and on the right side, x squared plus a different c. But 2c's subtracted is the same, is just another constant. So if I subtract two constants, I'm going to get just a constant. If we want to write it out, we would have gotten this. Maybe we'll say constant 1 and x squared plus constant 2. And if we wanted to rewrite it with both constants on the same side of the equal sign, constant 2 minus constant 1 is just some constant. So in general, for these problems, we just do 1 plus c, and we don't worry about having multiple constants going on in our work. So I'm just going to leave it as plus c. Let's erase this side work. Now that we've integrated, we want to isolate the y. So I'm going to start by multiplying both sides of the equation by 2. We get y squared equals 2x squared plus 2c. Kind of the same concept as before. 2 times a constant is still just some constant. So I'm going to just leave this as a c. Next step is I'm going to square root both sides. I'm square rooting both sides, so I need to insert a plus or minus. We get y equals plus or minus the square root of 2x squared plus c. And that is our answer. We're going to do a couple more problems. So just like before, this one is separable. So for this one, I'm going to multiply both sides of the equation by y squared. And I'm also going to multiply both sides of the equation by dx. Now that we've separated the variables, we're going to integrate both sides. On the left side, we're integrating with respect to y. On the right side, we're integrating with respect to x. So on both sides, I'm going to have 1/3, and then in this case, y cubed. Again, I'm going to put the c on the right side. Now that we've integrated, we're going to solve for y. So I'm going to start by multiplying both sides of the equation by 3. I'm going to get y cubed equals x cubed plus 3c, but just like before, I'm just going to make it a c. Next step, I'm going to cube root both sides. And we get y equals the cube root of x cubed plus c. And that is that answer. So again, our steps are separate the variables, integrate both sides, and solve for y. We have a couple more. So for number 3, I'm going to multiply both sides of the equation by cosine of y. And I'm also going to multiply both sides of the equation by dx. Now that we've separated the variables, we can integrate both sides. On the left side, the integral of cosine is sine, so sine of y. On the right side, we get x to the 4th, and it's technically 4 times 1/4, but that equals 1, so we're just going to get rid of it, and then we have our plus c. To solve for y, I'm going to do inverse sine on both sides, or arc sine, however you want to write it, is totally fine. So on the left side, we're left with y equals, on the right side, arc sine of x to the 4th plus c. And there is our answer. We have one more. For this one, I'm going to multiply both sides by this denominator right here, 2y plus cosine y. And I'm also going to multiply both sides of the equation by dx. Let's integrate both sides. On the left side, we're going to get y squared plus sine of y. On the right side, we're going to get x cubed. In the front, I have 6 times 1/3. Let's rewrite it one more time so we can simplify. We get 2x cubed plus c. I want you to notice for this one, there's no way to solve for y. So when you can't solve for y, it's okay to leave it as an implicit function. But if you can solve for y, you want to do that. So those are a few examples of solving differential equations using separation of variables. Thank you for watching.